Preparing for a SRE at Fastly interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you define SLIs, SLOs, and error budgets for a Fastly Edge delivery service? An SLI measures user experience, an SLO sets the target, and an error budget represents tolerated unreliability. For an edge service, I might measure successful requests, P99 latency, and availability by region in POP. I would exclude clearly invalid client requests, document the methodology, and alert on budget burn rather than every small fluctuation. If the budget is exhausted, I would pause risky changes and prioritize reliability work until performance recovers. While answering, distinguish measurement from objective and remaining risk tolerance. Discuss latency, availability, cache hit ratio, regional dimensions, burn rates, customer impact, and how error budgets guide release decisions. Question 2. A customer reports elevated 5xx responses in one Fastly POP. How would you investigate and mitigate the incident? I would first confirm the signal by comparing that POP with neighboring locations and separating edge-generated errors from origin 5xx responses. I would check recent deploys, configuration changes, saturation, dependency health, and request patterns. If customer impact is active, I would use the safest mitigation, such as rollback, disabling a feature, or shifting traffic where possible. I would establish an incident lead, communicate regularly, preserve evidence, and verify recovery through independent customer-facing metrics. Make sure to cover incident declaration, scope confirmation, dashboards, logs, recent changes, origin versus edge isolation, traffic shifting, rollback, customer communication, and post-incident validation. Question 3. How would you design monitoring for a globally distributed CDN service? I would combine request rate, errors, latency, and saturation with CDN-specific signals such as cache hit ratio, origin fetches, purge latency, and configuration propagation. Metrics would be segmented by POP, region, service, status class, and customer tier without creating uncontrolled cardinality. Synthetic probes would test representative URLs, while real user data would reveal unseen failures. Alerts should represent user impact or fast error budget consumption, with runbooks and ownership attached to every page. In your answer, talk about the 4 golden signals: synthetic and real user monitoring, POP-level aggregation, high cardinality controls, regional comparisons, alert ownership, dashboards, and actionable thresholds. Question 4. What is the difference between a liveness check and a readiness check, and how can misuse cause an outage? A liveness check asks whether the process should be restarted. Readiness asks whether it should receive traffic. I keep liveness simple, usually verifying that the process can make progress, because dependency failures should not cause endless restarts. Readiness can include required dependencies, configuration state, and warm-up completion. During deployment, failing readiness removes an instance safely, while liveness remains stable. Misconfigured probes can otherwise amplify a brief dependency outage into a fleet-wide restart storm. Be sure to mention process health versus traffic eligibility, dependency checks, startup behavior, failure thresholds, graceful removal, and why putting downstream failures in liveness checks can trigger restart loops. Question 5. How would you troubleshoot intermittent high latency between an edge POP and an origin? I would decompose latency into client to POP, POP to origin, connection establishment, TLS, time to first byte, and origin processing. I would compare affected POPs, protocols, routes, and time windows, then inspect packet loss, retransmissions, DNS responses, connection pool reuse, and origin saturation. Traces and synthetic requests from multiple regions help isolate the segment. I would mitigate with a healthier origin, tuned keep alive settings, routing changes, or caching, then confirm P99 improvement rather than relying on averages. Focus on separating client to edge, edge to origin, and origin processing time, include DNS, TCP, TLS, routing, connection reuse, packet loss, queuing, regional comparisons, tracing, and controlled tests. Question 6. Explain how you would safely roll out a change to a critical edge service. I would make the change reversible, version the configuration or binary, and define success and rollback thresholds before deployment. I would begin with a small canary, ideally one region or POP, while comparing errors, latency, saturation, and customer-specific behavior against a control group. Automated gates should stop expansion when an SLO or key invariant degrades. I would increase exposure gradually, keep the previous version ready, communicate ownership clearly, and perform a post-rollout review. Mention staged deployment, canaries, automated health gates, rollback criteria, regional exposure, configuration versioning, feature flags, observability, freeze windows, and proving reversibility before expansion. Question 7. How would you handle a configuration propagation failure across Fastly's global network? I would first determine whether the control plane accepted the version and whether each POP activated it. A propagation dashboard should show version identity, timestamps, acknowledgements, and regional gaps. I would stop further changes, compare behavior between old and new versions, and use a known good version or safe fallback if customer impact exists. Propagation should be idempotent, observable, and retriable. After recovery, I would reconcile every POP and test both new configuration behavior and rollback. Cover control plane and data plane separation, version identity, propagation tracking, idempotency, partial rollout detection, safe fallback, customer impact, consistency expectations, and recovery validation. Question 8. What is a good incident response process for a high-severity production outage? I begin by declaring the incident based on user impact, assigning an incident commander, an operations lead, and a communications owner. The team establishes a shared timeline, confirms scope, and pursues the lowest risk mitigation before debating root cause. Updates should state impact, actions, and next checkpoint without speculation. I preserve logs and deployment data while avoiding unnecessary changes. Afterward, a blameless review identifies contributing conditions, concrete owners, deadlines, and tests that prevent recurrence. In your answer, discuss severity assessment, incident commander, operations and communications roles, mitigation before root cause, regular updates, timeline capture, escalation, and blameless follow-up. Question 9. How would you investigate a cache stampede on a popular object? A cache stampede occurs when many requests miss simultaneously after an object expires or is purged. I would confirm the pattern through miss rates, origin request bursts, object popularity, and expiry timing. Mitigations include request collapsing, stale while revalidate, probabilistic early refresh, TTL jitter, shielding, and origin rate limits. I would preserve correctness for explicitly purged content, because stale serving has a freshness trade-off. The durable fix combines protection mechanisms with monitoring for hotkeys. Be sure to mention simultaneous expiry, request coalescing, stale while revalidate, TTL jitter, origin protection, shielding, purge behavior, hot object detection, and trade-offs around freshness. Question 10. How would you diagnose memory growth and possible leaks in a long-running SRE-managed service? I would first distinguish heap growth from page cache, allocator fragmentation, buffers, or memory-mapped files. Time series data should correlate resident memory, allocations, garbage collection, traffic, request types, and deployment versions. I would capture a profile or heap snapshot safely, compare it with a healthy instance, and reproduce the suspected workload in staging. During production impact, I might recycle instances gradually or reduce load, while preserving evidence. The permanent fix requires a regression test and a monitored rollout. Focus on baseline comparison, heap and resident memory, allocation profiles, garbage collection, traffic correlation, leak reproduction, container limits, behavior, and safe mitigation during investigation. Question 11. What Linux troubleshooting steps would you use when a service is CPU saturated? I would inspect per core CPU usage, load average, runnable processes, throttling, interrupts, and the specific process consuming cycles. Tools such as top, PIDstat, perf, and application profiles help distinguish user code, system calls, lock contention, and kernel overhead. I would compare traffic, request mix, and deployment history with a healthy host. Mitigation could include rate limiting, disabling an expensive path, or shifting traffic. Scaling helps temporarily, but profiling should identify the underlying cause. Mention identifying affected processes, load average, per core utilization, run queues, throttling, profiling, system calls, traffic correlation, recent changes, and mitigation without blindly adding capacity. Question 12. How would you design an effective alert for elevated HTTP 5xx errors? I would alert on the proportion of failed, valid requests over a meaningful window, preferably tied to an SLO and multi-window burn rate logic. I would segment enough to identify a failing POP, service, or customer path, but avoid noisy high cardinality labels. A fast window catches emergencies, while a longer window catches sustained degradation. The alert should include impact, likely dimensions, owner, and runbook. I would test it with controlled faults and tune it using paging outcomes. Cover user impact-based thresholds, aggregation dimensions, multi-window burn rates, symptom versus cause alerts, noise control, exclusions, ownership, runbooks, and testing alerts during controlled failure exercises. Question 13. What techniques would you use to reduce noisy paging in an SRE organization? I treat paging as a request for immediate human action, not a substitute for dashboards. I would remove alerts that merely describe causes or normal variation, consolidate correlated symptoms, and use slow burn rates for user impact detection. Lower urgency issues can create tickets with business hours ownership. I would review page volume, false positive rate, time to acknowledge, and repeated alerts regularly. Every page needs a clear action, an owner, and a tested runbook, otherwise it should be redesigned. In your answer, discuss page versus ticket thresholds, symptom-based alerts, deduplication, dependency-aware suppression, actionable runbooks, alert reviews, ownership, and measuring pages per engineer. Question 14. How would you use Terraform or similar infrastructure as code tools safely for production infrastructure? I would keep infrastructure declarative, version-controlled, peer-reviewed, and validated through automated policy and security checks. Remote state needs encryption, locking, access control, and reliable recovery. Changes should pass plan review, test in lower environments, and apply gradually with clear ownership. I would detect and resolve drift rather than silently overriding manual changes, except during documented emergencies. Reusable modules should expose safe interfaces, while production changes require observability, rollback planning, and an audit trail. Mention reviewed plans, state management, locking, modules, drift detection, least privilege, import strategy, policy checks, isolated environments, gradual applies, and emergency rollback procedures. Question 15. How would you design capacity planning for Fastly's globally distributed edge infrastructure? I would forecast requests, bandwidth, concurrent connections, cache misses, TLS handshakes, CPU, and memory by POP and customer segment. Forecasts must include seasonality, launches, flash traffic, and failure scenarios such as losing a neighboring POP. I would define headroom targets based on safe failover capacity, validate assumptions with load tests, and monitor saturation trends. Capacity work should begin before procurement or deployment lead times become critical. Over-provisioning costs money, but insufficient regional headroom threatens availability. Be sure to cover demand forecasts, peak and burst behavior, CPU, memory, bandwidth, connection limits, regional headroom, failure scenarios, load testing, procurement lead time, and capacity alerts. Question 16. A dependency becomes slow but not completely unavailable. How should an SRE protect the edge service? I would prevent the slow dependency from consuming all workers by using strict timeouts, bounded retries with jitter, circuit breakers, and bulkheads. I would cache safe responses, serve stale data where business rules permit, and shed low-priority work before core traffic. Retries must be budgeted because they can amplify load. The service should expose a degraded but predictable mode, with metrics showing dependency latency, queue depth, and fallback usage. Recovery requires gradual re-enablement rather than an instant retry storm. Discuss timeouts, bounded retries, circuit breakers, bulkheads, caching, load shedding, graceful degradation, dependency budgets, retry amplification, and communicating reduced functionality. Question 17. How would you troubleshoot a DNS-related availability incident affecting an edge application? I would query authoritative servers and several public and internal recursive resolvers from affected regions, comparing answers, TTLs, response codes, and DNS-SEC validation. I would inspect recent record changes, delegation, nameserver health, negative caching, and whether health checks removed all endpoints. DNS propagation is not instantaneous, so rollback may coexist with stale responses. I would use independent probes and direct endpoint tests to separate DNS failure from application failure. Longer term, I would add resolver diversity and tested failover. Focus on authoritative and recursive resolution, TTLs, negative caching, DNS-SEC, propagation differences, health checks, resolver diversity, recent record changes, and verifying from multiple networks. Question 18. What security considerations are important when operating an edge network and CDN? I would protect both the edge and origin using DDoS controls, rate limits, WAF policies, origin authentication, and restricted management access. TLS keys and API credentials require centralized rotation, least privilege, audit trails, and secure storage. Detection must distinguish malicious traffic from legitimate spikes, because an overaggressive rule becomes an availability incident. I would minimize sensitive logging, secure configuration delivery, and continuously test control plane permissions. Security changes need staged rollout and an explicit rollback path. Mention DDoS resilience, TLS management, WAF controls, origin protection, secrets, least privilege, abuse detection, logging privacy, supply chain security, and balancing blocking accuracy with availability. Question 19. How would you perform a blameless postmortem after a Fastly production incident? I would document what customers experienced, the exact timeline, detection quality, decisions, mitigations, and recovery verification. The analysis should explain how technical conditions, process gaps, tooling, and assumptions combined, without blaming an individual. Actions must be specific, prioritized by risk, assigned to owners, and given deadlines. Examples include safer deployment gates or better dependency isolation. I would track completion and later verify effectiveness through incident trends, slow data, and targeted game days. In your answer, cover customer impact, detection and response timelines, contributing conditions, technical and organizational factors, actionable follow-ups, owners, deadlines, and measuring whether fixes reduce risk. Question 20. Describe an automation project that improves reliability, and how you would evaluate its success. I would choose repetitive, well-understood toil, such as detecting a bad configuration rollout and automatically halting further propagation. The automation would use versioned inputs, idempotent actions, permission boundaries, dry run support, and explicit safety limits. It would emit audit events and require human approval for high-impact rollback when uncertainty is high. I would canary the tool and measure false actions, toil hours, mean time to mitigate, and related incidents. Automation should reduce risk, not merely move it elsewhere. Make sure to cover the operational pain, safety boundaries, idempotency, observability, human approval points, failure handling, rollout strategy, and measurable outcomes such as toil, MTTR, or incident frequency. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.